Okay. Good morning, everyone. We were talking about sensitivity analysis. We just started sensitivity analysis last Monday. Today's topic is, again, sensitivity analysis. I'm sure we will be finished with this set of slides as of today. All right. So, as we discussed, sensitivity analysis is what we're supposed to do if problem parameters change. So how sensitive is this solution in our hands to the changes in our environment, right? Then we also, so what are actually the environment settings to us? The parameters, which are the objective function coefficient, the right-hand side, or the consumption parameters, right? In addition to those three changes that can happen in the parameters, we may also be thinking about a new production, new type of product, so like a new variable, or we may be talking about a new type of constraint, right? So these 5 changes will be discussed in the context of the sensitivity analysis. But keep in mind, we will only consider one change at a time, all right? Remember this our good old matrix notation, because this actually will this matrix will be what we will be using, right, in determining what to do based on the changes. Now, remember both the primal and dual simplex, right? In an optimal solution, what do we have? We have primal feasibility, we have dual feasibility, and we have complementary selectness. Again, I repeat, in the simplex table like this, the X, which is B inverse B, and W, which is CB, B inverse B, always satisfies complementary selectness, right? There is no. Okay. We keep asking this to you. It was also in the poll question. So this X and W pair always satisfies complementary slackness. We stop when this W became feasible in the primal simplex, and we stop when this X became feasible in the dual simplex, all right? For primal simplex assumes this is non-negative. Dual simplex assumes row 0 is non-negative. So based on the change and which part of the table changed, we're going to apply the appropriate simplex algorithm, okay? That is what's being written in here. So based on the change, if primal feasibility is lost, that means dual is not affected. So we go from the dual simplex method. If the dual feasibility is lost, that means I'm still feasible. So I go with the current simplex method that we already know. If both feasibilities is lost, some changes might do that. In that case, it's the issue is more challenging. The idea is you may start from scratch. Okay, this is the example that we will be using for all the possible changes that we're going to discuss. Okay, so we have a maximization problem, okay, with enough slack variables. So we have 3 legitimate variables and 3 slack variables, all right? And this is the optimal table given to you. Now, one at a time, we're going to discuss all possible changes. We're going to start with change in the right-hand side vector B. Our original B here was 48, 20, and 80, okay? And this is B inverse B for the respective B inverse. And if you remember, B inverse is always hidden under the starting BFS. This is my starting BFS, so B inverse will be here, right? So B inverse times this will give you 2482. But let's see what happens if the 2482 is no longer like that. Let's remember, what I'm going to do is I will write this table format here so that we may use it. So we have B inverse A in here, B inverse B in here, minus C plus CB B inverse A in here, and CB B inverse B in there, all right? Now, when B is affected, let's see where B is in this table, all right? The right-hand side vector, little b. If you look here, sorry, little b has nothing to do in row 0, right? It's only here and in the objective function value. That means once we change the right-hand side vector, sorry, dual feasibility is intact. Yeah, because row 0 remains unchanged. Nothing is there. So what we're supposed to do, we will update the table based on the change. When we update the table, we're going to see that this part is not affected, but right-hand side will change based on the change in the B, okay? Because we still have this condition satisfied. We only need to see if the current optimal solution still feasible. If so, I will remain optimal because row 0 is already non-negative. If the current solution is no longer feasible with respect to the new B, that means I lost primal feasibility. I'll go from the dual simplex because the current solution in my hand is a legitimate simplex table for dual simplex, okay? So if we do not have primal feasibility, that means there is a K for which the right-hand side became negative. Now we will try to kick that variable from the basis. And for that, we're going to enter another variable from row 0 by applying dual simplex. Okay? Now, this is what we're doing right now. This is the optimal table. This was the original problem. All right? Now, the question is, so for which values of B3 does the current basis remain optimal? Current basis, current solution will always change. Be careful. Basis remains optimal, but the solution's value will be B inverse B tilde, and B tilde will be found by the new B. Okay? That you have to be careful there. The current basis will remain optimal whenever this B inverse B remains non-negative, right? Now, so my original B was 4828, and the question asks, how can I change B2? So 4828, and instead of B2, I just put a delta, okay? And I'll see for which value, because I'm questioning for which values of delta does this basis remain optimal. You just do the math, B inverse is here, and then this was B, but it's going to be 24, 8 plus 2 delta, right? So B inverse multiplied with B tilde, okay? Then I want this thingy to be non-negative so that my current basis will remain optimal, right? You just do the math. You see if delta is between, and this says greater than minus 12, greater than minus 4, less than 4. So if delta is in this region, which means what was B2? B2 was 20. So if B2 is between 16 and 24, then my current basis will remain optimal. Be careful, the value of the solution will change because values are based on 20. If your B2 was 16, your basis will still be optimal, but you will have to just update the solution vector. Okay? Now, so let's see what happens if B2 is 22, delta is 2. This is in the correct region. So I'll say current basis remains optimal. The value will change. If this B2 is 30, that means delta is 10. It's outside the region. Current basis is no longer optimal. I'll have to apply a dual simplex iteration, at least one. All right? I think we're having those, yeah. If B2 is 22, that means my delta is 2. You look at your B inverse B bar. This was what we ended up with, right? So you update your solution. Now, this is your new X. That's what I was talking about, right? Yes, my current basis remains optimal, but you still have to update this part because B has changed. It's no longer 20, it is 12. 22, sorry. It was 20, but now it's 22. It's okay. My current table will remain optimal. And this is the new table, by the way. This is the new optimal table. Still optimal, right-hand side positive, Rho 0 positive. So complementary slackness is satisfied. Everything is fine. Primal feasibility, dual feasibility, complementary slackness. But don't forget to update the solution. The current basis remained optimal, but you need to update the solution. When the delta is 10, you're out of the region because now your right-hand side vector becomes this. You have a -3 there, which is not feasible, right? So when you update the table, that's what's going to happen in the new with the new delta, okay? And this means this guy has to go and you look at the ratio test in the dual simplex. Only negative entries were valid, so there is only one. So X5 should be entering and X1 will be living variable, all right? And you do the iteration. After one iteration, you reach the optimal solution, which is given in here. Any questions from here? Is it clear, or do you want me to go over a part of it? And we'll wait a little bit until you, so that you actually think. And if you think it's fine, I'll continue with the change in the right-hand side vector. No questions. Good. Okay, then.
Someone is asking to explain the last part in the chat. They're asking.
Which part was sick?
I don't know. This Mustafa just wrote, like, can you explain the last part, please?
Can I explain the last part? Okay. Mustafa, which part are you talking about? You don't have mic? Do you have mic? I'll try. Okay. Whatever. What I understand from from my point of view, last part is as long as the basis remained optimal, how do you update the right-hand side? If that's what you're asking, okay? We have derived. Now, the condition we're checking is if B inverse B tilde with the new B remained optimal. Can you repeat the part where you said once we change the right-hand side vector, what happens to dual feasibility? I will, but today I'm hearing, why don't you ask? But you're right there. I might miss the chat part, but I'll do my best. Okay. When the right-hand side vector is affected from B to B tilde, all right? As you see from this, the matrix notation, only the right-hand side part is changing. Okay, so that means we may only lose primal feasibility. Dual feasibility has nothing there. Okay, based on the change, for example, we discussed like what happens if B2 was 22. If B2 was 22, if you put it and check, you're going to see that this B inverse B is still non-negative. That means I update my table with the new B. I just do these multiplications and I again get a non-negative right-hand side vector. My rho 0 is non-negative, right-hand side is non-negative, complementary slackness is already satisfied, so I'm optimal. Okay. But the result is current basis, the basis that I write with these variables is still optimal. Their values will, of course, change. Their values is B inverse B tilde with the new B, right? That's what's happening here. Their values are changing, and my objective function value is also changing with respect to new B tilde. But my current basis B is still optimal, all right? Now, if the change in that right-hand side is out of the allowable region, we did calculate an allowable region. And like if B2 was 30, and if you check B inverse B tilde with B2 being 30, you're going to see that your matrix, your vector becomes 44, 28, and 3, minus 3. So there is a minus and 3 in here, which means we just lost primal feasibility. That means, okay, my table will be like this. Yeah. In terms of dual feasibility, everybody is non-negative. Fine. But I do have an ambiguity in here. This means I can utilize dual simplex. If you remember from Monday lecture, that is when you can apply dual simplex, right? Which in the dual simplex, we were determining the living variable first. So this -3 guy is the one that we're trying to kick from the basis. So that this will be my living variable. And the entering variable for that will be determined by the ratio test of the rho 0 divided by the entry in here. The valid entries this time are the ones which are only negative, and among in the absolute value, we're going to choose the smallest entry, right? Now, there is only one negative entry, so there is only one valid entry this time, which means x5. So x5 is entering, and x1 is leaving. You apply the dual simplex iteration, which is being done in here, and the next table, right after the dual simplex iteration, you reach primal feasibility 2. You maintained dual feasibility. You have primal feasibility. Complementary slackness is fine, so we're optimal. So if the right-hand side, if the B becomes B tilde, you check primal feasibility. If primal feasibility remains, you just update your B inverse B tilde and CB B inverse B tilde as your solution. Okay? If the B inverse B tilde has some negative entries in it, that means primal feasibility is lost. So we're supposed to apply dual simplex. Any questions? John? İkinci rova ekledik. Right hand side'da ilkine veya üçüncüye ekleyebilir miydik delta'yı? Of course, that was just a question. My question was saying that how can we do for which values of B2? That's why. You could do for which values of B1. Yeah, try it as an exercise. Of course. Any other questions? Just be careful. You can do only one at a time. You cannot have two different things at the same time. The methodology I teach is valid for one change at a time. Okay. So we're done with the change in the right-hand side, B. Now we're checking what happens if we change C. Objective function coefficients, right? Remember, we had three parameters, B, C, and A. So let's look at the table that I've just written here again. I put one more little b, I don't know what. Okay. Now, when I change C, where do I see C? Right to the chat room immediately. Where do I see C? What happens? Which feasibility do I lose? May I lose? If I change the objective function coefficients. Yep, I'm getting very good answers. Thank you very much. You can still write it there because the chat room is going to be saved anyway. So if we change C, as you look at here, C appears in here. Yeah. If I change the rho 0 vector, objective function coefficients, my rho 0 will change. How will it change? Will be based on the change in it. So this time, I'm not changing the primal feasibility, yeah? Because the rho 0 coefficient. So I'm only questioning, is my choose of the basic variables still optimal or not, right? Now, just remember though, we have two different types of objective function coefficients. The coefficients for basic variables and the coefficients for non-basic variables, right? So C is actually CB and CN. The CB thingy appears in my dual variables, yeah? CN is not very effective actually. So we will analyze the changes in two steps, actually. First of all, this is true, yes. If minus C plus CB B inverse A, if minus C tilde plus CB tilde B inverse A is still non-negative, that means dual feasibility is intact, primal feasibility is intact. You just need to change this value this time if the C was in CB. That's all, right? Because it's not the value, the solution. The solution is B inverse B. But the objective function value may change or may not. So if the coefficient of the C, if the C that you're changing is to a non-basic variable, all you're going to check is it still better for me to keep this value at 0 level because it's currently 0. Yeah? On the other hand, so you only check that value. I think I have these in here. Yeah. Let's go from here. Now, CK is changed from CK to CK tilde. Now, the analysis will differ if CK is if XK is a basic variable or not. If it is non-basic, then there is only one entry in this whole table that you need to check. Only one entry is changed. The entry underneath XK variable, because CB is not affected. And this row 0 is actually, if CB is changed, you have to reconstruct all row 0. But if it is a non-basic variable, you only check the value underneath XK. That's what it says. Only row 0 coefficient of XK changes. You just check if it is still positive or not. If not, that means with the new objective function coefficient, increasing the value of this guy to a positive value is more profitable. So let's do that. That means this variable wants to enter to the basis because it has a negative entry. So you apply primal simplex as you always do. This time we have one row 0 entry in our simplex table, negative row 0 entry in our simplex table. If XK is due to a non-basic variable, and if you do the change and if it becomes negative. Okay? On the other hand, if XK is a basic variable, then our CB is changing. Now, when CB is changing, we have to reconstruct all row 0. Fine, still one row, right? You reconstruct the row 0 and you see if it is still dual feasible or not, meaning if everybody is non-negative or not. You reconstruct row 0, you just check. If there are negative entries, you just apply standard primal simplex. If everybody is positive, you're still optimal, just update your objective function value, CBB inverse B. All right? I think I have, let's go over the example if the methodology is clear. It's the same example. We will be using this example for the whole class today. This is the problem statement, optimal table. Now we're going to change. How much can we change C2? First of all, we need to go and see if X2 is basic or not, if C2 is in CB or not. As you see, my basic variables, X2 is a non-basic variable, right? So the change in C2, it was 30, will not affect the whole row 0. It will only affect the value in here. Let's recalculate that value. Yeah. So it is CBB inverse A2 minus C2, right? This is it. This is what I've written in here. This is my row 0. And you just need to calculate it for one entry there, for X2, which is, of course, minus C2 plus CBB inverse A2. If you do the math, this is what you end up with. The value is 35 minus C2 bar, C2 tilde. In the current thingy, it was 30. That's why we were seeing 5 there, right? 35 minus 30. So as long as C2 is less than or equal to 35, the current solution will remain optimal with the current simplex table. Nothing changes. Only this entry will change. But as long as C2 tilde is less than or equal to 35, my current solution remains optimal. If that thing is 36, I'll be seeing a minus 1 there, so X2 wants to enter. Okay? So if it is 40, for example, I will see a minus 5 there because it was the value is 35 minus C2 tilde. So you apply simplex. You have a negative entry in row 0. It's not optimal yet. This value enters. You do row 0. Well, you do the ratio test. There is only one entry anyway. So x1 lives, x2 enters. This brings you to the next table, which is the optimal with respect to the new C2. Okay? So for a non-basic variable, the objective function, the change in the objective function coefficient, you just check the row 0 entry of that variable. If it is still non-negative, nothing changes in your simplex table other than the row 0 entry of that guy. If the row 0 entry of that variable becomes negative, you just apply primal simplex because primal feasibility is intact, nothing changed in your right-hand side, so you just lose dual feasibility, which is then you need to choose primal simplex to go with. All right? Any questions in here? Okay. If we change, so how much can C1 be changed? Now C1 is but X1 is a basic variable, right? So C1, the change in C1 will affect all my row 0. So you have to do minus C tilde plus CB B inverse A, CB tilde B inverse A with the real new C1. That's what's being done in here. So C1 becomes this. CB becomes this. In the current version, objective function coefficient of X1 was 60, right? So the question asks, how much can we change it? The question could say, what happens if C1 is 80 or C1 is 20? Then you do it like that. But the question says, how much can we change C1? So let's see. We just update C1, but with 60 plus delta. Then I'm supposed to do C minus C tilde plus CB tilde B inverse A. I have to calculate this vector. Yeah? B inverse A is already here, but I need to calculate, it depends on which way you want to go, but you need to do this matrix and vector multiplications, all right? How we do that, we multiplied with CB, and then we subtracted C from that, and this is our new row 0, all right? You're supposed to add that to the it was not the final version. You need to subtract minus C also. So CBB inverse A minus C is what's written in here. I want this to be non-negative so that I remain optimal, right? That was what the question, how far can C2 change and we do not lose optimality. So we just calculate C tilde B inverse A minus C, and now we need to check the fact that each entry there should be non-negative. So each entry there should be non-negative. As long as my delta is within the appropriate region, you see delta greater than minus 4, less than 20, greater than minus 20 over 3. So if delta is in this region, my optimal solution will not change, right? And my objective function value is CBB inverse B. So my objective function value will always be 280 plus delta. I think we have this is how it's going to look like, your row 0, right? And as long as you're in the region, which means if C1 is between 56 and 80, nothing will happen. You will remain optimal. If not, if C1 is, for example, 40, then you will see that means your delta is there and one of these guys will become negative. On the other hand, someone else will become negative. Based on the value of C1, you will determine which variable is entering and you will apply simplex. That's how an inductive table looks like with the change of delta in C1. That's how, as you see, nothing changes underneath, only the row 0, but the whole row 0 is changed based on the change in C1. Any questions? Okay, we have seen change in right-hand side and we have seen change in C. Change in right-hand side in here, we may or may not lose primal feasibility. And if we lose it, we use dual simplex. Change in row 0 is here, change in C, right? We may or may not lose dual feasibility. All you need to check is check row 0. Sometimes you have to reconstruct the whole row 0. Sometimes you only need to check 1 and 3 there. But based on if it becomes negative or not, your decision remains. If it becomes negative, that variable wants to enter to the basis via the standard primal simplex. If not, you're still optimal. Okay? So we're done with B, right-hand side vector, and we're done with the objective function coefficient. Our next parameter is that the environment gives to us is the matrix A. All right? Now, this is a little bit trickier than the others because the matrix A, we're not going to change the whole matrix, of course. We're going to change the consumption vector of one of the variables. So we're going to change an AK in that matrix, a column corresponding to a variable. Now, again, we need to, this variable xk, okay, can be a basic variable or not. If that variable is a non-basic variable, life is easy, right? Because my B is not changed. But if that variable is a basic variable, look at my table. I'm seeing B inverse everywhere, right? So if you're changing the consumption vector of a basic variable, the life is challenging. We'll leave that for the next hour. But let's see what will happen if we change the consumption vector of a non-basic variable, because that means my B is still B. I didn't change that. I'm only changing an AK to AK tilde, but K is not basic. Okay? That means I just need to check one column in here. That kth column there, all right? And see what happens. First of all, since it's not in B inverse, right? If the AK is non-basic, which feasibility will remain intact, not changed? Again, write it in the chat room. If I'm changing the consumption vector of a non-basic variable, which feasibility is not affected? Mm-hmm. Yep, good. Thank you for listening. Good. Okay, yeah, you go on writing there. That means that A is not in B inverse, so it's not there. I'm only checking then for the new consumption vector, is the row 0 coefficient of this guy is still non-negative or not? If it is still non-negative, it is like I'm changing the CK, it will remain there. It's in the current value, I'm not producing that, was anyway. I'm just checking if with this new consumption vector, should I produce this one or not? If the row 0 coefficient is still positive, I will not produce that one. So my current solution with everything still the same. Inverse B, CB, inverse B, nothing changes. All right? You just check. Of course, you have to update your simplex table with the new B inverse A tilde and CB B inverse A tilde minus C. Right? So your new column, don't forget, you have to update your new column. Right? But if the row 0 coefficient of this new column remains non-negative, life is fine. What happens if the xk variable is basic? If I'm changing the consumption vector of a basic variable. Now look at this table. Even though it's messy, B is everywhere, right? So there are complicated. First of all, we may have negative entries in both sides. B inverse B might have negative entries. Minus C plus CB B inverse A might have negative entries. So we may lose feasibility of both. Well, we know how to deal with that. I'll teach that. But a more important issue is B inverse may not even exist. With the new consumption vector, the combination of the basic variables that you have chosen might not even give you a legitimate basis, right? In that case, you're dead. You go back, solve from scratch. We can't do anything, right? B inverse may not even exist. What we can do is we can have artificial variables with big M coefficients for the problematic columns and negative entries. Okay, you multiply with -1 and then add an artificial variable. And if you don't have an enough basis, you add another artificial variable, put big M constraints and go. But solving from scratch is pretty much the same thing. So we can solve the problem from scratch too. Any questions? Okay. Let's look at this example then. It's the same example, yeah. First, we're going to change A2. A2 in the current thingy was 6, 2, and 3/2. Okay. X2 is a non-basic variable. So we will start with changing the consumption vector of a non-basic variable. It was 6, 2, and plus 3/2, and this is its B inverse A2 value. Now, what happens if A2 was this? And C2 tilde, we're also changing C2 tilde. Fine. Anything related with the second variable. X2 is non-basic, only the second column of the matrix will change. All right. Let's calculate the row 0 coefficient, for example. It's minus. Whoa. It's going to enter. Yeah, because it's negative. But be careful. Before applying the ratio test, you have to update this. This B inverse A2 was respect to the original A2. Now I have to change the A2 to this value and then apply simplex, all right? Never forget that, because that part of the table is changing, so I am supposed to add it, right? So you look at do not forget. So you recalculate with the new A2. So your new column is -7, -4, 2. It has nothing to do with what's written in there, right? You have to change that. So you get your new table. This was the original table. This is the new table. It's a -3 and -7, -4, 2. Now apply simplex. There's a negative entry who wants to enter with the new consumption vector. The guy wants to enter. So it's profitable for us to produce that. So X2 enters, and with the ratio test, X1 lives. And I didn't finalize the ratio test thingy. Okay? Any questions? Now, we don't have an example when one of the bases changes, but the idea is the same, all right? You need to, like if I said X1 is a basic variable, so we might, if A1 tilde is something else, let's say, I don't know, 8, 2, 1, okay? I didn't change C1 tilde. You have to first update B inverse. You have to find the B inverse with respect to this B, then reconstruct the table everywhere, and then see what happens. All right? It's a mess. I don't think we will be asking this for you to do it, but we will be asking what happens, analyzing, right? So you have to know if the column of a basic variable changes, everything may change. Complications may occur, and complications include that B inverse may not even exist, or I may lose both primal and dual feasibility at the same time. Okay? So if the consumption vector of a basic variable changes, life is a lot more challenging. Complications may occur. You have to know those complications too. But reconstructing the table is, from my point of view, more work than solving the problem with this A2 one at the beginning and go with the simplex. Any questions? Was I too fast, or can you follow? Do you want me to repeat? Because we're done with the parameters. Now I'm going to add a variable and a constraint, and we will be done with the sensitivity analysis. So please ask, because I'm assuming you're following. I'm seeing from the chat room that you're also following. So, but if you have questions, please make me repeat one part. All right, then I'm going to add a new variable. So, changes. At the very beginning, we had a slide for possible changes. The possible changes could be right-hand side vector B, objective function coefficient C, or the consumption vector A. Based on what happens to my table, we go. Now, what about if I add a new variable? I'm adding a new variable. This is like, then it's a new X, right? Now this new X will appear as a new column then. Let me open a clean page and do this again. This is my B inverse A. This is minus C plus CB B inverse A. This is my B inverse B, and this is my CB B inverse B. Now, if I add any variable to my primal problem, that means I'm adding a new constraint to the dual, right? If I'm adding a new variable to my primal, that means I have to write a constraint to the dual. So, from this perspective, then, will I lose primal feasibility? Will I lose primal feasibility? I'm adding a new variable. Can my current solution remain feasible? And if so, how? I want to see hands. I want to see hands. I want you to talk. Yes, Ilhan? What do you think?
I think feasibility can remain if we add a really redundant constraint, then it can stay the same.
I'm not adding a constraint. I'm adding a new variable.
Sorry.
I'm adding a new variable for my primal problem. And I'm asking you, can my current solution remain feasible? So then, will primal feasibility remain intact? Think about it. The answer is already, you're seeing it on the board, but I want you to reason it out by yourself. Any ideas? Now, in my current optimal solution, which give me this table, all right, I didn't know about this new variable. So I may think about it like, okay, I'm not producing that. The new variable, whatever it is, here it's going to be X7. Well, I'm treating it at 0 level. So my current solution with X7 being 0 will be feasible, right? So the question is it still optimal? So is this new guy, new product, X7, more profitable to put it in the solution? So primal feasibility is intact. Dual feasibility may be lost. Why? Because a new variable in this primal problem is a new constraint in the dual. So all I need to check is the dual feasibility. Is it still there? So I put the new guy here, with B inverse A7 and minus C7 plus CB B inverse A7. Oopsie. All right. If this row 0 value of this new variable became negative, that means the dual feasibility is lost. I'm supposed to utilize primal simplex. Enter that variable, whoever is living. But be careful. Now you're having one more column in your simplex table because I just added a new variable. Okay? But that's all. So adding this variable, I may think of it as like, okay, I'm not producing it. So I'm putting it at the value 0. So my feasibility is intact. I'm just questioning the dual feasibility, which is my standard primal simplex algorithm, right? So you just look to the row 0 coefficient of this new variable. If that is positive, that means, okay, the marketing department come up with a new fancy product, but it doesn't pay off. I don't want to produce this. My current solution is still optimal. Else, if this new product's row 0 entry is negative, then I'll enter that, and whoever is living, and I'll apply my standard simplex algorithm. Okay? So this adding a new variable thingy is similar to what we do when we change the consumption vector of an unbasic variable, right?
Hocam,
so
is there no chance that the primal feasibility is lost when we add a new variable?
Is it? That's what I keep saying. Because it's just a new variable, right? So there's a new guy who wants to consume from the same resources. But I can say, okay, go away. I'm not giving you any. So this new variable, I can just say that, okay, this x7 is 0. When x7 is 0, everybody else was already feasible in my current optimal solution. So with the addition of a new variable, I can never lose from my feasibility because I can say, okay, I'm not producing you. I may lose my optimality because that decision, I'm not producing you, may lead to me suboptimal, right? So, but I cannot lose feasibility because I may say, okay, I'm not producing this guy, right? X7 is 0. I'm still feasible.
Okay, so I may assume that we are not producing X7.
I mean, I didn't know about it anyway. Now it's just on my table and they're asking me, should I produce it? And I say, well, I want to live with my solution. So first of all, my current solution is still feasible. That's what I'm saying at the beginning. I'm not producing. I didn't know that. So the value was 0 anyway. I know it. I still consider it as 0. I'm still feasible. But I have to check, should I produce it or not? That is checking for optimality, not checking for feasibility.
Thank you.
You're welcome. Thank you. Any other questions? Okay, let's leave this example to the next hour. I'm 1 minute late, so we're going to start at 41. Let me stop recording also. Okay, see you in 10 minutes. Have a 10 minutes break.